Well, hello everyone. Thank you for joining Did You Know, the ESCO HVAC show. Being joined this week by Todd Klur from HVACRedu.net. How's it going, Todd?
Howdy.
I thought I was going to be running on this one solo because I've got Ty, I've got Daniel, and I got Eugene all down at the symposium, down at Bryan Orr Symposium in Florida. We had AHR last week, which was insane. A lot of stuff going on. So this kind of segues into what did we find at AHR, right? We found lots and lots and lots of inverters, lots of A2L. We've seen a lot of communicating equipment. And I always kind of preach about the communicating equipment. And you and I, like, we have some fun conversations about, what is happening in the automotive industry, especially when we talk about communication stuff, right? Even in the
Indeed.
automotive, there was a time when every different manufacturer had their own code reader. You had to plug it in
hmm
and see what was going on a 5-volt DC communicating network, by the way, most of
Right.
the time, right? And so when we get into talking about new technology, a lot of us are uncomfortable with communicating equipment. Now, I'm going to break this into two different types of communicating equipment. We're only going to cover one today. Hopefully, we'll get through all of it. I got a ton of stuff for us to talk about. Today, we're going to talk about unitary communicating, and we're going to talk about all of the different manufacturers and how they really are on the same platform and how to test those platforms, how to see when you have problems on a network. And then on another episode, we're going to talk about let's call it ductless communicating, our higher DC voltage communicating platform. So, Todd, you spent a lot of time in the BEAS side of things, building automations, and you guys have got a great course over at HVACR EDU. And so, a couple of these slides are actually in reference to intro stuff into BAS because BAS and our unitary communicating really are very similar. Don't
The
you think?
six one half dozen the other, right? I mean, they're very similar the way they communicate. It's going to be a DC voltage, right? Usually a 5-volt DC, and very, very, very similar to a pulse width modulation. We may have heard that in the
Yeah,
industry, right?
absolutely.
Um, and so that communication here we have a master slave type application, and this
Sure.
is very similar to the RS-85 or cabling that we are used to. Usually a four wire lead wire,
Mhm.
and usually two communication and
That's right.
two or
That's right.
one for voltage for to
Mhm.
power the to the device. Usually 12
Absolutely.
volts, maybe sometimes 24, depending on the device,
Exactly.
and
Yeah.
then a common, right? You got to make that complete
Got
circuit.
gotta get a circuit. Hey, thank you, Howard. Yes, it is my birthday today.
Yes.
I'm so glad everyone's joining us. Where is everyone joining from? Todd, I know you're out in California. What part of California are you in today?
Southern California. So I'm actually coming. I born and raised in Upland. I moved down to Menifee. So wet Southern California today, not sunny Southern California. It is
Yeah.
wet today, and we got a big storm coming through. So yeah, that's where I'm from.
All right. I'm just outside of Brownsburg, Indiana. So when we look at that communicating platform, this is very important for people to understand that we're going to look at all these different manufacturers and you're going to see a similarity. You're going to see in a lot of these a 4-wire system, two that we're going to communicate on and two that we're going to supply power. Now, we do get into some differences in the way we communicate, but it is all very much the same. So if we look at this basic layout of what we call an RJ45 communication, so where we're talking about like Cat6 cables or when we're looking at communication cables, a lot of different industries use a same or similar platform, right? Oh, yeah, thank you everyone. I really appreciate it. So even our Ethernet cables, we're using a variable 5-volt DC. It's a 0.25, but it's plus or minus, and I'll show you what that looks like here in just a second, how we get to that. But we've got some supply voltages and we got some communicating voltages.
That's right.
Now, let's look at let me get a couple of these out here. We've got quite a few people hopping in the chat today. Thank you, everyone. I want to make sure that everyone's recognized for being here. Yeah, hey, I'm on my birthday, hanging out on the show. Woo!
Yeah.
So let's look at, and we're going to go through all of our manufacturers here. And there are some that are better at giving information into it, and then some that are not. So, Todd, you want to break down just a little bit about how some of the decoding side?
Yeah. So we most of us, at least in the residential or unitary type split systems, are accustomed to 24 volt,
Yeah,
right? Um,
like a switch.
and usually that's done. So I'm going to kind of combine this slide and next slide. I believe they're kind of overlap here,
Sure.
but it's our thermostat. In a 24 volt system, we have a thermostat. In a communicating system, it's no longer a thermostat; it's now
Same.
a
It's a network.
control or
Yeah.
controller, right? And the 24 volt system. It's just the thermostat is just a fancy switch,
Oh,
and it
like
sends.
light
It's
switch,
gonna
on or off.
it's gonna be a light switch, right? But in this case, 24 volts,
Yes.
typically. And in doing so, we either tell the heat to come on, or we tell the compressor to come on.
Single command.
Of course,
Single command.
yes, a single cam, or sometimes in some cases, two speed, right? We have a two-speed condenser, right? It's still not communicating. Okay, but when we dive down that communicating, where usually we get that four wire, two
Mhm.
communicating, and two other 24 volt or 12 volt, depending on the manufacturer, and a common, right? So there's your
Right.
four. We're going to get to some of those illustrations here in a minute.
Mhm.
But yeah, just like the very top paragraph says, 24 volt system. Call it Y for cool for call, G for fan, etc. But you know, that DC voltage is usually 5-ish volts, and it'll pulse width, right? So
Get some
it'll come
modulation.
on. It exactly, the voltage come on for a half a second, millisecond, and go off. And that language, or how long it stays on or off, is interpreted by a language, and
Mhm.
usually a protocol. And that protocol um, will speak to that controller or module, or the PC board that it's communicating with. Inputs, outputs, right? We're going to get those signals from thermistors, pressure transducers.
We're gonna
And
calculate all of them, do things with them.
it's going to say, hey, at this pressure, at this temperature, do this, or hey, do this when you get to these pressures or temperatures or whatever it might be.
And we do it in those pulses, and that's the important part
Correct.
to understand. Remember that AC was just a simple command, 24 volt, on or off. Well, we're now going to do this in pulses that are going to be on or off, but the amount of
Time.
time that we are on and the amount of time that we are off are going to be the language that we're speaking. And many of our different manufacturers use different languages. We're really just talking about different spacings within
Hmm.
the modulation, right? And
Ones
we
and
can,
zeros.
yeah, it's all ones and zeros, and we can actually read that. Now, we're not going to go this deep on it. We're not going to bring it on oscilloscope, although maybe down the road we'll do this so we can actually talk about it a little bit. So if we were to put an oscilloscope on a communicating network, we're actually going to see our ones and zeros, but we're also going to see those as a positive reference to ground and as a negative reference to ground. We're
Hmm.
actually going to go both directions because they came from our AC sine wave. So the important thing to remember is all of these DC communicating voltages started with our 24 volt AC power supply. So where do our DC circuits begin? Typically, it starts at our indoor unit. For residential unitary split systems, it starts at our furnace or our air handler, where our original power supply was at. So we'll take that AC voltage, we'll turn it into a VC, the DC voltage, and then we will start pulsing that thing. All right. Now, we have a ton of stuff to get through here. So hopefully we'll get through all of them. If you have any questions along the way, or if you have any input deeper than what Todd and I already know, bring it on. We want to get better at this because I'm telling you, a lot of this stuff, you got to dive deep into
Hmm.
service manuals to even find it. I've had some of my own technical friends that I called to clarify some of my own data, and they're like, "Where'd you find that?" I'm like, "Service manuals." And where we're supposed to find it?
Yeah, you made mention that we get that transformer of 24 volts from our indoor unit.
Yeah.
Do keep in mind this is unitary, usually a
Yeah.
split system. Now, when we do go and talk about split, or a typical or a ductless split
Ductless
system,
system.
then it's coming from the outdoor unit.
Yeah.
So
Where our
just
board.
keep that in mind.
Right.
Everyone's
And
going, "Hey, time out! That comes from the outdoor unit." Yeah, in a
exactly.
ductless
And
system.
our inverters that have a power supply at the outdoor unit, they will typically have their own as well. And we'll
Yes.
show you a little bit on that, what that one is. So for those that are comfortable with the Daikin platform or the earlier Goodman Amana stuff that was using the Climate Talk platform, let's look at this real quick. Remember those four wires, Todd?
Yes, I do.
What we're going to use in this particular platform, we're actually going to use two of those for 24 volts AC. So that great big colorful screen that we have on our thermostat, right?
Light up.
We still need to light up. If we put batteries in it, we know what's going to happen. That we had seen that back in the early 2000s when you put batteries in a
Yeah.
digital thermostat, you burn them up. So we're actually going to use two of those for 24 volts AC, R and C, just like normal. And that common is actually very important. It is a reference to remember what we do with the 24 volt side of the transformer? We ground it, right?
We
So
have to.
we have to. So on a grounded transformer, our common is actually connected to ground. This is very important when we start looking at and testing the communication. And Kyle, yeah, Kyle just came in and said there's 5 and 12 volts on the motherboard, not always, but often. And we are going to cover both of those
Mhm.
because we do have multiple ones. We'll have 5-volt systems, we'll have 12-volt systems, and we'll get into the ductless. We're actually going to get up into that 50-volt DC side that piggybacks AC.
Yeah, it's
Ooh,
really weird.
that's going to be a very interesting one, right? All right. So not that rabbit hole, not today. All right. So we look at this communication. So we're going to run 4 wires from the thermostat to the indoor unit. And depending if we're talking about like the FIT system uses a electronic expansion valve, we've got a board on that as well. So we're going to use AC for powering our controls. We're going to use our communicating the 2 wires. They're going to do this on number 1 and number 2. And so they're going to supply 2 wires to the outdoor unit. And when we're using a communicating outdoor unit, the board of the outdoor unit actually has a power supply built on it. So we're not going to be connecting R and C. We're just supplying the 2 wires. But if we have a bad ground within the system, we can really have some issues. And I'll talk about
Yes.
that here in a minute once we get a little deeper into what's going on with these wires. It'll make so much more sense.
And you could see that what go back to the
Yeah.
slide, Clifton. You could see what Clifton is talking about. The outdoor unit, the one on the very bottom there,
Yes.
has no RNC hooked up to it because
No.
why? It has its own transformer.
Yeah. So even if you have those terminals, we're not using those. And it's very, very, very important, the reason that we're not using it. And we'll talk about that. All right. So what are we actually doing to get those DC signals? Well, with this particular platform and with many of them, when we take our AC sine wave, we actually, because we have a grounded circuit, we have a reference point. And so now we'll actually utilize the voltages that are above neutral or ground and the voltages below. So we're going to have one signal that's in positive reference to ground and one signal that is in negative reference to ground. And that is the number 1 and number 2 wires. So when we use our circuit to be able to rectify our AC, we're going to get a DC looking signal because it's going to be chopped off. And now we're going to do these pulses within it. Think about it as like SOS, inside of that wavelength, right?
That's a great way to explain it. It is your Morse code, right?
All it is.
Yeah.
Just our spacing, our timing is
And
all we're actually doing.
that zero voltage baseline. I don't know if y'all remember maybe in some of the furnaces you plug in and if you have a 2-prong and you don't have that ground
Grand.
and then all of a sudden your PC board doesn't
Your
work
board doesn't like it. This is
because
why
it
we're doing
has
it.
no reference to ground.
No reference point for our voltage. So those 2 wires have a reference to ground. That number 1 and number 2 have a reference to ground. And there's a difference between the 2 of them that we're going to call the bias. So with this particular system, this climate talk system that we're using with Daikin and some of the earlier Goodman and Mana stuff, we are going to be able to measure from ground to number 1 and from ground to number 2 and get 2 different voltages. And what a lot of people don't realize is that difference between them, that bias is actually our bandwidth. So about a year ago, I did a class with John Brown over at EWC where we went really deep into this exactly. So if you want to learn more about that on this finished edited video, I'll make sure to put a reference to get back to that one so you can understand what that entire bandwidth looks like, how to set the bias, if your bandwidth's not good, how you adjust that. But for today, we're not going to go that deep. I just want you to understand when you're looking at that, we actually have those signals above ground and below ground in reference, right?
Mhm.
So some positive, some that are actually negative. So if we were having a problem on a communicating system on the Climate Talk network, we could actually take our meter and we could measure from common over to number 1. And we should be reading a positive 2.8 volts DC. There is a difference when we have an air handler. It only uses 3 volts DC. And we can actually talk about that. If they're really interested, I can show you the math on how to figure out the bias on an air handler that's using 3 volts DC and 5 volts DC. It's simple. You take the 2 that are on number 1, you add them, divide it by in half. Take the 2 for number 2, add them, divide it in half. And so the difference between those should still be that 0.6 volts DC or greater. Now, if we took our meter and we went from common to number 2, we're going to see that we're going to have that 2.2 volts DC. It's a negative, right?
Yes.
So we have a positive and then a negative voltage gives us a bias of 0.6 volts. Here's the thing. If we do not have 0.6 volts DC bias or greater on the Climate Talk network, you're coming back. It's that simple. It really is. You can literally measure between number one and number two. And if you have less than zero point 0.6 volts DC on a Climate Talk network, you do not have a stable bandwidth. You have conductors that are corroded because a mouse has chewed on them. You have conductors that have kinked or broken. You have conductors that are not landed properly on the terminals. You have wire nuts sitting outside from your existing solid
Yes,
wire that got water in them that corroded and no longer allow the communicating voltage because we don't have the amount of current that we had with AC.
that's right.
Very, very, very low current. So it's super simple to check the bandwidth. So if I'm an educator, I'm bringing in a new Daikin communicating system, I'm connecting it, I actually can now show my students how to make sure that my network is good and operating properly. If it's not, this is where you start. You start on the bias voltages. So if I am trying to isolate a system, say I've got all these components hooked up. This particular one, I got my thermostat, I got my indoor furnace, I got my cased coil, and I got my outdoor unit. If I am struggling for communication, I just start it. Where would I start, Todd? Where does my DC voltage begin?
It's going to be at the ground. You got to get a reference point.
Got to get a reference point of ground and power at our indoor unit.
Yes.
So, worst case scenario, disconnect all your wiring, check it, make sure we got our 2.8, 2.2, or our zero point 0.6 bias difference at our indoor unit. It's going to be 1.9 and 1.3 on an air handler, but it's still a 0.6 difference. And then start adding my parts. When I add something on and my voltage bias changes, guess what?
Point 0.6.
If it's not, I've just found my problem.
Yes.
Now, I will talk about one really oddball one that I have found, and after I found it, it made sense. Look at that outdoor unit. I got two wires, right, going to the outdoor unit. So I'm communicating my DC voltages. So where is my reference point, Todd?
From the indoor to outdoor,
Yeah, there's no wire.
there's
Where
no
would my
wire.
outdoor unit find as a reference to ground?
Well, it is connected to hopefully a disconnect. That disconnect hopefully is grounded. So
Back
you
to
got
the
equipment
electrical
ground back
panel.
to
Exactly.
the
All right.
panel.
Yeah. So I had a technician that called me and said, "Hey, I've got good bias voltage at my indoor, at my thermostat, and my EEV, my outdoor unit. I've got some janky voltages and my bias is not right." I'm like, "Well, that's really interesting. Let's check your voltages to ground," and check the voltages to ground, and they were low at the outdoor unit. So I had him disconnect the wires from the outdoor unit, check the wires going to the outdoor unit. The wires were good. So as soon as we connected it to the outdoor unit, the voltage dropped. And I thought, well, maybe it's a board, or is there something else? I thought, well, let's go check all of our ground. And we
Yes.
found a corroded lug inside of the disconnect that had poor connection. So the path could not make it back through the electrical panel to the indoor unit. The reference point was bad. Clean the
And
wires.
I've seen on rare occasions, by a handful of times, maybe half a dozen times throughout my career, the UFER, the residential or even commercial, the UFER it got corroded, got
Yeah,
water on it, and that UFER, that reference ground, that rod that goes
yeah,
what 6, 8 feet in the ground was corroded.
yeah, absolutely. Remember on that AC system that was using 24 volts AC to run a contactor? It didn't care. It had enough AC voltage running to the compressor. Probably may not have been the safest thing in the world, but it didn't affect the way that our 24 volts AC operated contactor, but could absolutely with the communicating system. So I have had incidents where I had bad ground wiring that was not able to be reconnected properly. And so we would simply connect common from the indoor to common of the outdoor. Cannot use R because we
Yes.
already have a power supply at the outdoor unit on those, but we could use common as a backup. Okay, so that's an overview of our Daikin. We learn a lot about what's going on, in that one. So let's look at the other networks and see how similar they are. Now we'll see one in the JCI side. A lot of times you'll see it referenced as Echelon. It really is their communicating system.
For
Yeah, I see two primary um, connections because they've had a couple different generations of it,
yes, they
right?
have.
So you'll see one that is labeled ARCB, primarily using green, red, black, and blue or white wires. And then you can also see a variation of that that is just common B and A. And I like finding this one in their service manuals. Remember, almost all this comes right out of the service manuals. It's not like hidden stuff. You
Yeah.
have to read it to find it, but it's in there.
You have to
And
read?
you have to read, right? Yeah, Pat, Murph, that is a great point. Let me hop over here.
Oh,
You know,
yes, Murphy.
that ground rod is Yeah, absolutely. And we got places out west that don't have ground rods. They have, ground arrays where they have
Mhm.
shallow, wide grounding. But it is absolutely in a dry condition, it becomes less of a conductor. So it's very important to understand that that ground is part of our communicating network. We didn't think about that before, but it is now. So let's look at this JCI one, and we'll see that either way you look at it, we've still got a common. We have A, which is our positive reference,
Mhm.
and B, which is a negative reference. If we go back to the other diagram, which is their newer design, we still have R, we still have common. You just have B on the end and A on the end.
And go back to the other slide there. Check
This
that
one?
out. You got what? A positive
Yeah.
and B negative. Gee, I
Yeah.
wonder which one those are without even referencing what A and B are.
Isn't it that it's amazing when you look at this from the perspective because remember, a lot of us, I would say most of us educators, we're technicians out in the field, many of which never worked on communicating systems. And so sometimes we're a little leery to bring communicating systems into the classroom because we don't completely understand them. Well, you get done with this class, you're going to go, that's all? Bring it on because I've got this. This all makes sense. Everyone's really doing this and they're just saying it's different.
Yeah.
Yeah, pretty much.
It's just a different it just matters a different protocol, a different language. But
Exactly.
it's being delivered to one piece or one controller or the unitary devices in the same way, just a different language
Different
itself.
language. Now, I will say that I cannot speak for the bias voltage between 1 and 2 for the rest of the manufacturers. I know the climate talk pretty well, and there's a lot of training material for that. So if there's anyone out there that has tested the bias voltages and know more about the bias voltages between different manufacturers, I'd love for you to hop on because that's a piece that not every manufacturer likes for you
To
to
disclose either.
disclose. Right. So I'm curious myself, but I mean, I've got my own ideas. But let's talk about how do you check these? Okay. So if we're talking about this particular network,
Let's make this bigger, Clifton.
let's hop you and I out of here so we
Yeah,
can see that a little bit better. And I'll put us down here in the bottom.
there we go.
It's literally just another checklist, right? So with this particular one, so if you think there's a communication issue, you're being told in the service manual to isolate A plus and B negative, right? And then measure the A plus and B terminals to what common.
To common, to a
Back to
reference
common.
point.
Back to our reference point of common once again. And so this particular one is done a little bit different because they are utilizing voltages at each different part. And so they're saying, all right, let's just make sure that if we're going from A to C isolated, that we're going to have 3.2 volts, and B to C is going to be less than a volt DC.
There you go.
Right.
Yeah.
So it's really communicating positive from A to common. At the indoor unit, we're checking A to common, we're checking B to common, outdoor unit, A to common, and B to common. And if you look at it, it's simply stating we've got a 3-volt DC power supply on these instead of a 5-volt DC power supply.
And each manufacturer will be different.
That's right. But
It
how
goes
do we
back to that protocol language.
It does. How do we check them? We simply open up the service manual
Mhm.
and verify the voltage. You're going to find that some of these look really similar to each other when
Yeah.
we get into it. All right, so let's take a look at the infinity line. Most people are comfortable with infinity. I have a lot of people go, man, I really struggle with my communication line, especially if I get into zone systems. And I'm like, well, let's just understand what we're doing on that zone system. Let's look at the entire system. What is infinity? It's 4 wires, okay? And they are going to be labeled A, B, C, and D. Now, if I were just a guessing guy, Todd, and if I didn't go into the next slide we're getting ready to look at, I might look at that and go, I got 2 wires going to my outdoor unit. I wonder what's on those 2 wires.
Gee, I wonder.
That
Well,
might,
if it's the outdoor unit, it probably has its own. If it's communicating, it
if it's
probably has
communicated,
its own transformer.
right?
Well,
On power
we
supply,
aren't going to have. We usually don't have common hooked up.
right? And we don't need,
Rarely ever,
yeah, right?
unless we have a problem like you described. We're
Exactly,
not going to have R hooked up. So the
right?
only other two wires there, in this
It's
case,
my
green and yellow,
it's my
one's
communicator.
got to be one's got to be a positive DC and one's got to be a negative DC.
All right. And then from my indoor unit to my thermostat or whatever I got 4 wires. So let's take a look and see what those actually are. Well,
There we
looky
go.
there. So you got to break it down a little bit different from this manufacturer, but let's start at the very bottom. And either one. Let's just start at the top.
Okay.
And if we go from C to D,
Hmm.
well, That looks awfully hot to me.
And looks awfully familiar.
That looks like an R to me, and they're all in reference. A, B, and C are in reference to C. A
See,
and B are both in
common.
reference to C, and D is in reference to C. So C must be common. So C is actually common, and D is actually 24 volts hot, and A to common, I'm going to have a 3-volt DC signal, and B to common, I'm going to have that point 0.1 to point 0.3 volts DC.
And of course, that little tilde is approximately 3 volts, approximately 0.01 volt
Exactly.
to
And
point
so
0.3.
they are showing you to reference it a little bit differently. They're saying, hey, on the top reading with the board power applied, so I've got power going to the board, but no
Mm-hmm.
units connected. This is the voltage you're going to see coming from the indoor unit. And then once I connect things, I'm going to see a change in voltage, and I'm going to see it moving between 2.5 and 3.9 volts DC. And so that is how you test that communicating network on our Infinity system. Let's just keep
And
on going.
and anything outside those parameters, we got a problem.
You got a problem between them. You know, if
And
I
it
look
could
at that,
and it's usually, typically,
yeah,
your wiring. It's
absolutely.
usually not the controller. It's usually not the board.
Yep. The only thing that I don't see in many of these, except for the very first one, is measured between A and B, which that would be our bias voltage.
Mm-hmm.
So I need to round up some is what I need to do.
Yes.
I need to get in some of my friends' labs and go, all right, what's the bias voltage on every one of these manufacturers? Because I got a feeling they all operate under the same principle that if I have a certain bias, then if it's below this, I can't communicate well.
So what are we looking at here?
All right. So this is another one from the same manufacturer in a training manual that I thought would be very interesting to see.
And my guess is it's got 1,000 is kilos. So are we talking ohms?
We are talking the power supply on our DC controls.
Okay.
So if let's just, because all I'm doing is I'm converting my AC signal to a DC, right? So I've got a circuit. So this particular manufacturer actually goes deep enough to say, hey, after you've powered everything down, after you've had enough time for all of the capacitors to drain their
Drain.
voltage, you could actually disconnect these control wires and we can tell you what the resistance of that board should be so that you know if your DC power supply is actually good or not.
There you go.
Well,
So they
that's
reference our ohms and thousands. And
1,000.
if it's anything outside those parameters, I imagine they give you a plus or minus in most
Plus or minus
manufacturers.
10%. If it's in or out, that can tell you if your board's bad, if the
Yeah.
power supply of your board is
Just
actually.
like we do PSC motors, compressors, you name it,
I'm starting
anything.
to see some similarities in here,
Yeah.
right? If we know how to use a meter, we can work on these really scary inverter modulating, communicating things that are out there. There is more service data for these systems than there are for anything else that we
And
work.
the beauty about communicating systems, we forgot to mention that or touch on that, is they're efficient.
Oh my goodness, absolutely. Yeah, I need to do a class on what the modulating uh, algorithms look like because of that they make so much sense when you look at what. Because one of the big things, well, how do they know when to ramp up and down? It's just simple math.
And sensors, and it's your pressure transducers and your thermistors.
That's
They
it.
all communicate with each other, inputs, outputs. Take our BAS course for example. Ron Alville does a great job explaining your inputs and outputs, more so on a commercial application. But guess what? You just described it earlier.
This is
It's the
exactly what
same
we're
thing.
doing. So all of these new pieces of equipment that we're running into, it really is not that difficult to understand them. You just have to take the time, hang out with us, and let us show you how these things work, right? So on this particular one, A and B are your communicating, C is common, and D is just 24-volt hot. That's
Yep.
all it is. It's just power for the screen, and then we have a couple of DC communicating lines. All right, let's take a look at Linux iComfort system, right? Woo! I like those. Good pieces of equipment. What do they do? Wow. They get kind of crazy with the wiring diagrams. Let's stare at this for a minute and go, man, am I really going to work on this thing? Yeah, yeah, you are. Let's break it down a little bit simpler. We can look at this one or we can look at the one after it from another piece, and it sometimes makes it a little easier to understand what those four are doing. All right. Let's start at the indoor unit, Todd.
All right, let's go to the indoor unit. And
All right.
interesting that everything's tied back to the indoor unit on these unitary. Yeah,
Yeah.
it'll be completely opposite when we get to our
The
ductless.
ductless, absolutely. But all of our unitary, our primary DC voltage is coming from that indoor control board.
Yes.
So let's look at this indoor control board. This one's using a smart hub because it's connecting another component to it, but we can even talk about the smart hub if we needed to. But what do you see at that indoor unit? What are you
We
see
got
4 wires?
Yeah, I do. I got a R, forget I don't see and a common. So the R and the
Mhm.
common I imagine be 24 volts, and the one and the two in the middle, I see a negative and a positive. I can't read what they are,
They call it
but
I, but it's I
okay, I.
positive and I negative.
So there you go. And I wonder what those are.
Right? So, as elusive as these may seem, they're really not. One difference that we do see with this particular brand is we may not be using that 24 volt AC all the time. We might have a 12 volt DC. So, if we hop over to the smart hub up here, when we get to our smart hub, we
Drops it down.
originated with 24 volts AC and our two communicating. When we go out of our smart hub, we're actually going to now start using a DC voltage to work with, but we still have our A and B or positive
Are
and
still
negative.
a communication. Now, interesting enough, a lot of manufacturers you'll see some of them say, "Hey, you need to use shielded wire, or you need to use
Good
stranded
point.
wire."
Yes, yes.
And does anybody see, or I'm going to kick it to you,
Yeah.
what's interesting going all these
Y
wire nuts?
I
What's
think this
going
is a
on
great
here?
one. Everyone in the chat, look at this and give us some thoughts. And I know some of the platforms, it takes a minute to chime in, but we wanna know what your perspective on there because there's something interesting happening here with the shielded wire. Now, this could be unshielded, and we're going to do something with it. So give me
And
an idea.
this typically is your 18 whatever,
Yeah.
18.7, 18.8,
Control
whatever
wire.
it might be. Your typical thermostat wire, not non-stranded.
Mhm.
It's better to use stranded, of course,
I
but
prefer. Yeah.
I prefer, right? But nonetheless, I've had very little problems with solid core wire before, but stranded's always better.
Exactly.
Anyway, those wire nuts,
Yeah.
for anybody who wants to tell us what's going on there, looks like it's all going back to the indoor unit.
Why would we do that?
And
Oh,
then trace it down, you go to the outdoor unit, but hey, those extra looms or extra unused wires
unused wires.
are not hooked up to anything, but they go back to a common. Everything's going
Hmm.
back to common at the indoor unit.
Sounds like some kind of grounding to me.
Maybe kind of a pseudo in a way of a
How
shielding
about that?
wire.
How about turning a non-shielded wire into a shielded
It's
wire?
not really what's going
Kinda like
on here,
a wire.
but it
Yeah,
helps
helps
prevent
break up the interference.
some of that interference.
Exactly. And so when you look at the manufacturers, there's always the big question of, do I use shielded or do I use unshielded or non-shielded wire? And some manufacturers will be very specific that you should use shielded wire for your communication. And then some manufacturers will say you can use shielded or unshielded as long as you're making certain precautions along with that. So I've seen it both ways and I've had success with both types of wire. But if we are using a unshielded wire, we can help that circuit, give it a little bit of additional protection by creating a grounded shield within part of the
Pseudo.
pseudo shield because it's not all the way around because
Yeah,
what if the wires you're all using are on one side and the rest of them are just
exactly.
but it does give it some shielding, right? And good call, Kyle. So it's very
Yes.
specific on here. We don't want to
And
create a path,
for anything. Yes. So
any
that's
kind of
why it all
interference.
goes back to that indoor unit as we see.
Our primary source. Because what if I have power supply at the outdoor unit, power supply at the indoor unit, and I have a loop between them on this particular one? It says, no, we don't want you doing that. We want to make sure it's only done
At
connected
one
to the
location.
indoor unit, right? Okay, so mystery gone out of that. It is a 4 wire system, common, hot, plus, negative. How do we check the voltages on that? It's actually pretty clear right out of the service manuals. It depends on if it's connected. This particular manufacturer says, let's check it a bunch of ways. We could check it if we're, now you'll see this term that you don't always see, naked, loaded, landed.
Yes.
What do those mean? Well, here in the service manual, if we go back up to the top over here on the left-hand side under definitions, it says naked. Control has no wires on it at all.
Jeez.
So no equipment. So
It's
this
just
particular
wires.
it
It's just
so
conductors.
it's yeah, we're just checking with nothing connected to it. Loaded. Voltage from the common to the plus or the negative when all 4 wires are on.
Okay.
Okay. And then landed is voltage from common to negative or positive without the R wire connected, the 24 volt hot,
Okay.
right? Add an additional load into that circuit. So we're simply checking for voltage. So if we were on a gas furnace, we can go from common to positive and common to I. We're going to see around 2.8 volts DC. If it's
Mhm.
naked, 2.6 loaded, 1.9 landed. So they're very specific on what the voltage should look like. Now, nothing about bias on these. I don't say most of our manufacturers don't talk about bias, but that bias would tell me if my bandwidth is good. So what we're doing with this particular service manual is just simply saying that these are the voltages we should see at our plus and minus terminals in reference to ground. If it is this plus or minus 10%,
You're
you should be good.
if it's not,
If it's not, start
check.
unplugging.
You
Yeah,
start unplugging, check your conductors, check your where all the terminals, check your ground reference.
absolutely. Hey, Pablo, thanks for joining us. All right. Buenos Aires. That's a
Yeah, that's a
little distance. Thank you for
it is.
joining and hanging out in our community today. So I get this quite often. All right. So what if I'm checking these voltages and my voltages are bad going to my outdoor unit? Something's not quite right. I go, well, um, it depends on who installed that control wire. If it was an electrician, I can about guarantee it's got staples in it,
Oh,
right?
geez.
May have rubbed over time, may have some oxidation on the exposed copper, may not communicate properly. Very first thing I do, I disconnect my wires. So I leave them naked or I use them as loaded, not landed.
Yes.
Check my voltages. And if my voltage for my indoor unit is good, I open the closest window. I go grab me some fresh conductor and I throw it out the window.
That's exactly what I do.
And so I run a fresh conductor and then retry it because you
Yes.
will have nuisance issues with communicating wires on existing on existing thermostat wires that didn't have any problems when you're running a contactor. When I
That's
had a
right.
contactor, my current was going through the conductor, right? I was utilizing the entire um, circumference of my conductor to get my current through to create a load on my contactor. With communication, a lot of times I'm running around the surface of it. Yeah, I'm not putting a lot of current through it. So I'm actually
It's
communicating.
sensitive.
It is very sensitive. So if I have oxidation, if I have cuts, nicks, breaks, I'm going to
Or
be more.
splices.
So
Oopsies.
if you're on a communicating system and there's an existing splice and your control wire, very first thing you do,
Run new wire.
you well, good call. If you can't run new wire, the second thing you should do, you go grab your snips and you cut it off. You clean it to fresh copper. You put a new wire nut on it, or you put a
You don't even use wire nut.
clip.
Solder.
That's
Because even a butt connector can corrode.
exactly, and that's what I would say. If you're using anything other than a solder, if you're using any type of solderless connector, make sure that you fill that with silicone or dielectric grease when you're done, so you don't get
I
any
agree.
moisture for any oxidation down the road.
Yes.
All right. So another manufacturer debunked. Not a big deal. We got four wires. Two are hot, two are communicating. If we're using the smart hub in this particular brand, very clear. Positive to common, around 3.5 volts DC with it naked. Negative to common, around 1.5 volts DC. I would love for somebody out there in the community to check that bias between positive and negative for
Yeah.
me and see if that
If they
happens.
know, let us know.
Yeah, because I got a feeling we're going to see that. I said that's just another topic. It's one of them rabbit holes I haven't went down yet. I'm hoping somebody will do it for me. All right, let's dive into Comfort Link, another great communicating system out there, right? How does it work?
Hmm,
Okay, maybe a tad bit different.
a little bit different.
So, um, all right, so I've got at my indoor unit, I've got I got B, R, and D.
Huh.
My outdoor unit has got B and D.
Well,
Okay.
our outdoor unit only needs communication. So what's our
Yeah.
communication?
All
B
right.
and D, process elimination, right?
Process of elimination. So we're using B and D for our communicating wires. What's interesting when you, because remember we had four before, right? On a lot of these manufacturers, and this one only
Mhm.
has three, but notice what B has next to it. B's got a common.
Yes, it does.
So when we start talking about communicating ductless systems, we're going to be talking about piggybacking AC and DC voltages on a single wire.
It's a ghost voltage.
It is. And that's actually what we're seeing here. We are seeing two 24-volt AC connections and two DC connections. We just happen to be sharing a
The same
terminal
as and a conductor.
and a conductor. So our B is actually a B/C, right? So it is common. And then we have R for 24 volts hot. And then, of course, now we have our other D for communicating. So when we look at voltage wise, what are we doing? We are not running on 5 volts DC on this particular platform.
Much higher.
We are running on a higher DC voltage. Now, when we start getting into our commercial equipment like the BACnet and a lot of our other communicating platforms, like you cover on your BAES
Mhm.
course, you're going to spend time talking about this. But how do you measure? Is it any different?
No, it just whatever the manufacturer is using, hopefully it's within parameters.
Exactly.
So open up that literature.
And so we got a parameter. And so they're telling us if I measure between D and B, so I measure between our 2 points of communication on common communication, I should have 12 volts DC between D and B. I should have good communication.
Hmm.
If I read 16, I've had a lost communication. That means things are not connected. And then if there's less than 12 volts DC between D and B, something is grounded, something one of my wires has landed wrong, or I simply don't have power, or I burn up a power supply on my indoor unit, right? It's always possible. So it also says, the voltage may fluctuate while devices are transmitting on the communicating bus. So we may
Yes.
see that move a little bit. That's another good comment that Kyle put. Kyle, I'm glad you're joining us today, man. These are a
Yeah.
lot of great conversations. And I know this is right up your alley. It creates an
Yeah.
echo chamber and messes with communication.
Yes, it
Absolutely it does.
does.
So run all in new stranded wire. I
And
prefer
shield it if the
shielded.
manufacturer requires it.
Yeah, if the manufacturer specifies it, you better be doing it. Otherwise, you're going to have some problems. But just be cautious of where could we lose communication. Well, now we've covered a lot of them, and now we're showing you how you can actually check them. So let's jump over to some of our ICP products. Right,
Gee,
we
I
got
wonder if this is going to be similar to Carrier.
kind of looks a little similar. Now they've had
Huh.
two different generations
Yes,
too,
they
though.
have.
So you're going to see Observer, you're going to see Ion, and I'm going
Yep.
to show you a couple different wiring diagrams. But let's break it down. All right, let's put it into perspective.
Looks pretty similar.
What do you see there, Todd?
A DX positive, DA or DX negative. I wonder
Right.
which ones those are. Maybe
And
data?
right. In our indoor unit, it might call them A, B, C, and D, but then all we got to do is we got to look at the wall controller, or we look at the outdoor unit, and we see exactly what those things
Yep.
are. So I see 24-volt hot between common and D or
Yep.
R. And then I see a negative communicating signal on B or DX negative and a
Mm,
positive on A.
honey.
Looks pretty dang familiar. Wonder if we can check this one. Well, why
Look
not?
at that. And
So now
geez, doesn't that look similar to what
I'm not
Carrier
even
was
gonna
doing?
go there. Wait, we name
Gee,
throwing.
I wonder why.
Well, we're just saying that their training material on their slides look similar. That's
Okay.
all. That's all we'll say. So, yes, DX negative to common. That is common. Commodore 24 volts. So we're just on 3-volt DC. We're going to see 3 volts on both of them. And if we don't, we got to disconnect and we got to start seeing where we're losing it. So the best way
Yes.
on any communicating system, disconnect your control wires, start at that indoor unit, verify you got good voltage coming from it, and then start adding them one at a time. Let's look at Comfort Sync, right? Let's look at
Do
some
you
of these
think this
outliers.
might look similar to Linux?
Well, look at that. I'm seeing common, I'm seeing R, I'm seeing positive, and I'm seeing negative again.
And look at our pseudo shielded cable with our
That's a
typical
little
18
familiar.
gauge whatever.
Mhm. Yeah. So if it's a non-communicating wire, we got communicating existing wires. Boom. We're going to tie those together, and then we're going to check our voltages, right? So it's the service instructions are a tad bit different,
They're a bit different.
but this is because of the communicating platform that they're using. What we're checking changes. How we check it never
Never.
actually changes.
Yep.
So we know that it's a 5-volt DC system, right?
Yep.
So we can now check the pin 1 to pin 2. We should have 4.5 to 5.5 volts DC when it's not communicating. So when it's sitting there idle. Pin 3 to pin 2 should read 4.5 to 5.5 when it's not communicating. And then pin 2 to pin 4 should read 4.5 to 5.5 volts DC.
Geez, they all look like 4.5 to 5.5.
I'm telling you. That's why I like doing this class. Because when you go through it all and you go, oh,
You know,
really?
you
Oh,
know,
this all
this
makes
is
sense
this is
now.
your typical multimeter here. Go back real quick. This
Yeah.
is your typical standard multimeter you carry in your tool bag all day long. You don't need an oscillator tool, and just to see the actual pulse width modulation.
No,
It's nice to see it, but it's going to mean nothing to the technician unless you know how to read that language or
that's
that
exactly
protocol,
right. What we're there to do is to make sure we have a good network.
and
Remember, it's
it's
about the
within
network.
parameters.
Yeah, it's within a perimeter. If it's out of perimeter, well, we're service technicians. We got to go
Why?
find why it's out of perimeter, and it's going to be a bad.
Usually, your conductors
It's
of
going to be.
some nature.
I have people all the time. But that control wire is great. It worked great for my old system. Now it doesn't work on this new crazy inverter. I want a new product. And I go, did you run new wire? No, I've never needed to run new wire. Did you check your wire? Well, how do I do that?
Run new wire with that out the bedroom window.
That's a quick way. That
Yeah.
is a very quick way because most of the time we do find our issues in our conductors. We really do, and it's hope it's starting to make sense to everyone that we all are using a same platform. Now we are starting to see some variations of that. I want to kind of talk about that real quick, just so that you understand the difference, because we have my T87, my favorite thermostat there on the right.
Yeah,
I love my T87s. Right, great thermostats. What if
it's
I
one of
want
the
a
best.
what if I yeah, and
Reliable.
I actually do. I've got a Nest here at my house, and people are like, I hate. I like mine. I'm fine with mine.
I'm
But
gonna hold my tongue on that.
what if I want to put a communicating system on my Nest or my 50, 60, 70-year-old T87 round that I love? What if you're going to put a communicating inverter system modulating gas furnace into your 90-year-old grandmother's home, and she says that if you take off her T87, you're not coming to Thanksgiving?
You're gonna need a translator.
Okay. So let's look at some of the options out in the industry for communicating systems that are hybrid communicating systems. So remember I said earlier about the older Goodman and Amana stuff? They used to use Climate Talk as well. A lot of manufacturers used to use Climate Talk or a version of Climate Talk. There was actually a Climate Talk Alliance back in the 1990s.
Hmm.
So when we talk about some of the newer products, just say Goodman and Amana communicating. Well, they're still using the Climate Talk, the Comfort Link, between the indoor unit and the outdoor unit. So the indoor unit is still generating the 5 volts DC. If we look right here, our indoor board has got our 1, 2, R, and C
See,
going to the outdoor unit. That's our two communicating wires, our positive and our negative. But the indoor, we're actually on a separate plug going to a legacy style thermostat that uses switches,
typical old school 24-volt.
whatever you want it to be. T87 round. Okay. So what's happening here? Well, we're just simply using a call from our thermostat, and then we're going to use algorithms on the indoor board to dictate the staging up and down of our communicating signal to our outdoor unit. That's it. So we're still using our 5-volt DC, the exact same 5-volt DC signal that we're using on all of the new communicating systems. We're using it from the indoor unit to the outdoor unit. And we're just going to allow you to use a legacy thermostat to run that communicating system. And that's interesting, isn't it? And how do
Yeah.
you test it? The same way we do the rest of them.
I mean, on the T87 or thermostat side, what are you supposed to have? 24 volts. On the communicating side, whatever the parameters are by the manufacturer.
That's right. So with theirs, typically, if it's a gas furnace, 2.2, 2.8 with a 0.6 volt DC bias between the two of them. And it shows you exactly on that outdoor unit where our 24-volt common is grounded to our chassis, to our
Yes.
grounded circuit. That is actually how we have our common reference from a ground of the outdoor unit or common in the outdoor unit
And
to
back
common
to
of the
the
indoor.
back to the panel,
Back to the panel. The panel is our
the
loop
service.
back to
Yes.
our indoor unit. So if I, like you said, if I had a furnace that was tied onto an old 2-wire system coming from a plug in a basement, and I put a new communicating system in it, it doesn't communicate, guess where my problem's at?
Got a bad ground, or in this case, a bad reference.
Exactly. That is exactly right. Now, so that was, we don't have to hang out on this. And this is just part of that Cool Cloud app that they're using. So I can remotely control all that communicating stuff with my legacy. There's other communicating systems, and I just want to kind of clarify those. We still got a few minutes left. I want to kind
Mhm.
of talk about those. I don't know if I got a diagram for that. I should have double checked that.
Honeywell's red link.
Yeah.
Yep.
So when we're talking about things like our, let me back up real quick. When we're talking about our red link stuff, so Prestige IAQ system, which is using red link, we're actually using a wireless
Yes, we're going to
communication.
the wireless and some form of Bluetooth, Zigbee, Z-Wave,
Exactly.
whatever kind of frequency.
So even if I only have two wires now, Todd, going from my control board of my Prestige to my thermostat, I'm not using communicating because what do I need those two wires to be?
They just need to be to power up the device with whatever, if it's 12 volt, whether it's 24 volt, whatever the PC board or the controls allow or
Exactly.
want.
So it will talk wirelessly
Mhm.
back to the unit. The whole Red Link system does that. So on those wireless systems, Red Link is using 900 megahertz. Wi-Fi is, 2.4, 2.5. So those are just different communicating platforms depending on what you're working on. Now, DC voltage wise, our other commercial networks are using some similar voltages, right?
Very
They're doing,
similar, usually
doing
10 volts.
exactly. So they're doing the exact same thing. Why do we increase voltage? Hey, Todd, why do we increase voltage on an electrical supply line overhead?
Maybe because
So we can go
otherwise, if
further?
we didn't, we'd have to run a conductor a big.
That's right. So that's the reason we use higher voltages on some of these.
It's
It's not,
pressure.
it's just
Voltage is
pressure.
pressure.
Exactly. We get to run longer control wire at a smaller diameter. So that's all. But they are operating in the exact same scenario. So for those of you who figure this and get comfortable with this and go, well, that's not bad. And you can go, well, now you can become a BAS technician too, because now you're starting to get it. We're going to add some intricacy to it, but that's really what we're starting from. We have manufacturers like Todd, you and I just talking about this one. This is my
Yeah.
personal favorite zone control. Remember, we don't have sponsors for this program. So anything that you hear from us, this is all personal opinion. This is not someone paying us to even be here. We're getting paid here by our employees, the ESCO Group and HVACR EDU, to educate the industry. So thank you all for allowing us to. Can you believe we get paid to do this?
Yeah.
I know it's a lot of fun. My personal favorite is the EWC 3000 UT 3000 Ultra Talk
And I mentioned to you, I said, hey, this kind of looks a lot like the Honeywell
in
zone
design.
board.
Yeah, the
And it's
interesting interesting thing is they work very closely with some of the manufacturers. The UT 3000 they work with Daikin, and here this is what's really interesting about this. If you look on that side, this is a zone control board that allows you to use
either option.
on a communicating system, right? So it's got to be a communicating indoor unit, communicating outdoor unit. You can use either a communicating thermostat or a legacy thermostat.
But what
Your
language?
zones. Yeah, so this is only for the Daikin
There you
network.
go.
I'm surprised that we don't have these for every other manufacturer. Part of that, talking to my friend that's the engineer for this board, he's like, manufacturer just won't give us all of their data for
Yeah.
what the language they're speaking.
Well, maybe one day, just like we have at Lawn Talk versus Modbus, we'll have a Niagara system that can
A
translate.
universal communication for unitary
Geez, wouldn't that be nice?
wouldn't
Similar
that be
to
great?
our OBD2 terminal, like we are talking with cars. It
Ah, I
makes
just
sense, wouldn't it?
it would make so much sense if we can, as an industry, coerce our manufacturers to use a unified common platform so we have a controller. I mean, it just basically becomes an OBS system for our industry. Right?
Yeah.
That's all. All right. So all they're doing is they're taking analog inputs from a thermostat and they're creating the um, outputs in communicating to run our communicating system. Now, here's what I find intriguing about it. There's actually other products that have been out there on the market that some have been around long enough that they've even been discontinued.
Yes.
If we look at this particular one, so with this particular manufacturer, they had a board that allowed a communicating outdoor unit and a communicating thermostat to talk to a non-communicating furnace. Now remember, Todd, when we were talking about communicating systems, where did the communicating DC voltage begin with?
Indoor unit.
So if I don't have a DC power supply at the indoor unit, what do I do?
Well, maybe it's coming from this relay panel.
How about I just give it a DC? So it literally takes our 24-volt AC from our non-communicating furnace, turns it into a communicating DC signal to talk with the thermostat and the outdoor unit, and then it just changes our fan speeds.
And or
So
compressor speed if it's
or
if it's a 2-speed, or if it's variable, it'll modulate.
exactly. So it goes back to it's just another communicating platform. It's turning an analog signal into a digital signal, and that's what that particular board looks like. If any of you have ever
Yes.
seen that, so it is out there, allows some communication, but it has since been discontinued. And I look at that going, uh,
I wonder why.
wonder why. All right, so let's look at another one. This particular one is just called an interface. This particular interface is very interesting because this is a segue, Todd, into our next communicating
Yes.
conversation.
Ductless.
This actually allows your indoor unitary unit to talk or communicate with a ductless outdoor unit.
So you're saying you could use a traditional air handler, standard air handler, non-pancake coil, non wall mount ductless, but say you wanted to use a traditional air handler ducted,
Yeah,
and you could use this module here or this interface,
yeah.
and you could run an outdoor variable speed modulating uh, ductless mini
If
split condenser.
if I had a ductless outdoor unit, where's the metering device for it
It's
on the outdoor
usually
unit?
it's on the outdoor unit.
Look at key considerations. Number one, indoor coil metering device must be
Must
removed.
be moved.
So we're absolutely
Well,
just
that
talking.
goes down another rabbit hole. Make sure you insulate both those lines there.
Make sure both those lines are insulated because exactly right.
Otherwise, you might have a little wetness on that drywall or whatnot.
That's
But
exactly right. But it all comes down to communication. How do we communicate? It's simple. We've only got a couple languages. This particular interface looks at both of them and says, well, that's no big deal. Let's do it. So communicating really is not that difficult when we step back, look at it. Well, thank you. I appreciate that. It has been a great birthday. I get to hang out with all of you. Are you kidding? This is a wonderful birthday.
I'm I'm lucky. I get to hang out with you on your birthday.
I love this, man. This is so much fun. And I've even got my red velvet cake blizzard from Dairy Queen. Today's the
There
first day
you
of it.
go.
I wait for that every year. So good. So good. All right. So back on topic just for a second. We got a couple minutes left. All right. So man, I think we're gonna get through almost all of this, Todd.
Yeah.
So there's another one out there. So this is actually a new piece of equipment. It's been out for a few years. It's actually one of my favorite pieces of equipment. It's the Daikin Fit. So that's a 17 SEER inverter. Here's the interesting thing about it. They actually have a component called a gateway that would allow you to use that communicating outdoor unit. And remember, my case coil has an electronic expansion valve in it, so it's going to be communicating as well as like a communicating thermostat, but I can actually hook that up to a non-communicating gas furnace.
And you mean you get the efficiency of that variable capacity outdoor unit? Imagine that.
And, it's it. So if you think about it, a lot of our AHRI ratings are for a time delay relay, right? There's so that gives you an AHRI rating for an inverter system with a time delay relay, not necessarily
Yeah.
variable speed motor. So I wouldn't think we get the total efficiency, but you still get to use the component. The interesting thing is what we mentioned again. You know, where do we get our DC power source for a communicating system? Well, typically on our furnace. But what if we're using a non-communicating furnace that doesn't have DC power supply? We just add the gateway, which gives it
Or
theirs,
the interface, yeah.
the interface. Oh, that's a great question. Is there a book for this class? There is not, but I tell you what, or I
I
I
can answer that.
I'd say you'll see some of this material in the very near future getting utilized in some inverter books for sure.
Yes.
Todd, for sure, some of those first slides are. Todd,
A
tell
lot
us
of those slides, yeah, a lot of that information comes from a lot of our training material here at HVAC. In fact, you go to our website. There you go. Thanks,
about.
Clifton. He's already prepared.
I'm trying to stay ahead of the game.
Little heads up. Look for on our website. I was told that we're running a promotion for Valentine's.
Oh, really?
Yes, I think I don't quote me on this, but
Okay.
marketing was pushing around a 20% coupon up until
Ooh,
the 14th, and then falling to a 15% post that
wow. All right. There
store
you go.
wide.
So you want to dive deeper into BAS? All right, here was your introduction, and we'll I tell you what, you can actually this video will be back on our e-learning network with continuing education certification attached to that if you're interested in coming back and going through this and taking a test. And now
Yes.
you got the foundation for getting into BAS
And
education.
we also partner with ESCO, HVAC Excellence, and you
Absolutely.
could even access our BS courses through their website.
Yep.
But I don't know if the promotional work that way because you go through your store then. But at
Probably
least
not.
up until the month of February, up until the 14th, we're doing that promo.
Okay. That's fantastic. All right, that is it. Remember, I talked about that Climate Talk Alliance? These were some of our early manufacturers that all agreed that we should have been on a common communicating platform.
Oh yeah.
All of them signed on, and unfortunately,
Interesting how we don't have what would you call them? The big
I'm not going
three, the
there.
big four?
I'm not putting any names out there. I'm just
Well, you
saying
aren't putting any names out there. It's right there.
that's right. So we're saying names that are not on this list. If we could get them all to working in a common communicating platform that many other manufacturers already wanted to do, then it would sure make a technician servicing side a lot easier.
A lot easier.
All right.
Wouldn't have all these different languages that you have to learn, right?
I know it's kind of crazy. All right.
Well,
Well, let's talk about a couple other things real quick, Todd. Let's talk about National HVACR Education Conference.
yes.
I'm assuming you're going to be there hanging out with me.
Will I be there?
It's
Come
going to be so
on.
much fun. I can't. I mean, we're going to do podcasts and we're going to do so much stuff there.
We're gonna have a blast. Um,
We are.
I can't tell too much, but some
Yep.
big news is coming in the industry,
All right.
specifically from us.
We're going to hear it at our conference.
I very well think you might.
All right. So everyone join us at the conference. And if you'd already planned on coming out there, get there early. If you hadn't made plans to do anything on Sunday, we want you hanging out with us. Daikin is going to do a very, very special 100-year celebration. So Daikin has been in the industry for 100 years. They want to hang out with you, have a good time. I can't give you details on that either, just that
Yeah,
it'll be fun. So
yeah,
everyone join us. And anything else, Todd? I think
yeah. Let's if you guys need to get in touch with me, Clifton did put up our website up there. You can get in touch with me. My first name's Todd with two D's, and at hvacrdu.net, not a .com, but a .net, as it says right there behind my wonderful head.
yeah. Right, right.
And of course, they can get in touch with you. I imagine so too.
Yeah, and give me a shout at cbeck@escogroup.org. And I think that's a wrap unless anyone else has some questions. I know there's still a lot of people hanging in. We're glad to see you all here. And
One last thing I'll put in
yeah,
there is that communication systems are here to stay.
they are. And we're
They
going
are
to be seeing
not going
more
anywhere.
and more and more. And hopefully we'll end up persuading a common
Common language,
communicating
common protocol.
common platform. All
We'll
right,
see.
Todd. Once again, always fun hanging out with you, my friend. I love these conversations, and it's just about bringing quality education to the industry. So
Yep. And one final, as
yeah,
before we say goodbye,
yeah.
happy birthday to my best friend Clifton.
Woo! Thank you, everyone. You know what?
All right.
I had people saying, what kind of glitter are you
Yeah.
wearing today? And I was like, I don't want to do this the whole time, but
How
I,
come you don't have your get up from AHR?
I just picked it up from the dry cleaner, so I got
Ah,
prepared for our conference.
there you go.
All right, everyone. Thank you so much for joining us once again. We'll see you all next week on Did You Know? The ESCO HVAC Show. Bye.
Bye bye now.